Morning, everyone. Can you hear me?
Morning,
Morning,
ma'am.
ma'am. That means you can hear me. Till now, only five students. I just wait for a while. Still, okay. So today we are going to see types of linked lists. Okay. Let me share the screen first. So basically, there are main three types of linked lists: singly linked list, doubly linked list, circular linked list. Then circular doubly linked list is again a type of circular linked list. So you can say basically three types of linked list. One is singly, one is doubly, and one is your circular linked list. So what's the difference between them? Our first is our singly. Singly linked list is your simple normal linked list. Okay, the linked list we have already discussed about like daily. Those are our singly linked list. So what happens in singly linked list? There are just two fields. One holds your data and other holds the address of the next node. Correct? It just has address, 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 and suppose this is your last node, this will just point to the null pointer. Then there will be another pointer head which will point to your first node. So in singly linked list we always have to start from the head, then from the head we just move on. Okay, now we have the other type is doubly linked list. So what happens here, it has three fields. In case of in a single node of singly linked list, we have two fields. One is data, one is address of the next node. Now, in case of doubly linked list, we have three fields. Okay, here we have three fields. So one field will just keep your data. The other, the next field will have the address of your next node, which will point to the next node. Then I'm just writing next, and the front part will have the previous node pointer. That means it will again have a connection backwards. Okay, so if here we have three nodes, we will have previous and next, and we have data here. So next will point to the next node, and the previous node will hold the address of the previous node. Okay, and similarly there will be a head here which will point here. And now the difference is just that this first node, you can say the front node, the first node will have a null pointer here. And in case of last node, if it is our last node, it will have the null pointer. Okay. So the difference between singly linked list and doubly linked list is that singly linked list we have just single pointer that will point to the next node. In case of doubly linked list, we have pointer for both previous and the next node. Okay. So one node will consist of two fields other than your data field. Okay. So total three fields here, and here's two fields. Okay, one is address for the next and the data here, data plus pointer for the next and the pointer for the previous one. Now for the last node, it's same. The last node will always point to your null pointer, just that the last node will also point to the previous node as well. And for the front node, it has the pointer to the next. Again, it will have an extra null pointer in the front. Then head will again same, it will just point to the give the address. So if this is the address 200 and 300, suppose, so you can say next will be 200, and here previous node will have 100, which is the address of your first node. Again, address pointer of your address is 300, correct? So 300 is the address of the next, so this will come here. Again, you just need to point it here. It will be 200. So last node will just point to your null pointer, which is your 0, and the front one also will just point to 0 because there is no point in front. Head is not a node. Head is just the address of here. So head just has the address of your first node, correct? So this is doubly linked list. Is it clear? The difference between singly linked list and doubly linked list? Okay, Pilar said yes. Others? Yes. Okay. So can you tell me what's the advantage of doubly linked list? Please repeat again. Okay. জ্যোতিষ্মা singly linked list to বুজি পাইছা? In a node, we have two fields for the normal case. External user guest is waiting in the lobby. Normal node, we have two fields, correct? One is for your data and one is for your address. Address means address of your next node, correct? So in double linked list, what happens? We have the data field, we have the address of next node, and we also have the address of the previous node. Therefore, there are three fields in a node of your doubly linked list. Okay, that means what? We have two connections, one forward and one backward, correct? That's the advantage of your doubly linked list as well. See, in case of singly linked list, we cannot move back. We always have to start from the head, then we have to move to the next node, then next point, and next node. But we cannot backtrack, correct? One node just give the address of your next node, not the previous node, correct? Suppose you are in this node now. You can go to the next node, but you cannot go back to your previous node. Why? You don't know the address. And this is not contiguous memory, right? In array, it's contiguous. You can just move back to your previous. In array, what happens? From this point, we can go back here, just telling you the index. With the help of index, we can just go forward and backward. But in case of linked list, we cannot go backward. Why? Because it can be stored randomly in your memory. So only with the help of address of the next node, you can forward move to the next node. So in case of singly linked list, we cannot move backwards. That's the problem, and to overcome that problem, doubly linked list is used where we can move forward and backward as well. Why? Because a node contains both data, address for the next node, and the address of the previous node. So you can say you won't get lost in a doubly linked list. If you want to go back, then you can go back. You just need to follow the pointer because it already has the address of the previous node. Is it clear? And in case of doubly linked list, since it has a three fields, address next and address for the previous one, in case of front node, there is no previous node. Correct? No previous node means what? This data field will just point to 0. 0 means you are null. Correct? Therefore, in case of doubly linked list, we have two null pointers. One for the front and one for the end. In n also, there is no next pointer address because that's the last one. Therefore, address is 0. Therefore, two null pointers in case of doubly linked list. And head just stores the address of your first node. Okay, clear, right? Now, just think how we can add or delete items in a doubly linked list. The process will remain same. We can add or delete item either at the end or at the beginning and even in the middle in the required location. Just the difference will be that in case of singly linked list, whenever we add an item, we just add one link. here we need to add two links. Okay, suppose you want to add item in the front, okay, at the beginning. Okay, suppose I have a node here. So I want to add it in a doubly linked list, right? So there will be three fields. One will have a data, and I'm just giving the address. Okay, I'm just telling the address is 500 maybe. Okay, right now I'm just giving one address. Okay, let's not first give anything here. Just that we have a node here. I want to add this data in the front. Okay, add in front. What we need to do?
We need to add the address of the front value, that is 100, and we have to change the front means the previous link of the front value.
Yes, correct. So we will simply remove this front one. We will point it here, and this one will also point to, sorry, this node won't be here, of course. Okay, let me draw it properly. Just that we need to add two pointers here. Okay, one will go forward, one will go backward, then head will point here. So here will be your null pointer, and the address will be 200, which will be held here. Okay, that means, okay, here I'm just removing the deleting as well, but I don't want to delete. If I don't want to delete, what I need to do? The thing what I just now did is I deleted the item, then I added. This is not the case actually. We just need to add here. We need to add here. Oh yeah. So your address will be 100 here, and the address of this one, suppose address was 500, so your head will be 500 here. This is the address of your new node. Okay, is this clear? So this was front, the front, this one won't be any front anymore. The new node will be your front. So what I'm doing, I just created a node, and the location of this node is suppose 500. So what I need to do, I just need to point to the first node. I'm just changing the head link. It's similar to your singly linked list. We are simply changing the link of the head and pointing it to the first node, and just creating the two links with the first node. Only difference is we are adding two pointers now. One will point to the first and one will point to the second. So in this case, this will be changed to, correct? What will be the address for this one now? This is your second node now. This is your front. What will be the address here? this is your second node now, and this is your first node now. This is the pointer for your next node, and next node for this particular node is this one, address of 200. So if it is your second node, after inserting this new node, this previous node will contain the address of your first node, which is 500 in this case. Is it clear? Want me to repeat? Clear, ma'am. Okay, repeat again. Okay, I repeat then. Okay, so this is our normal node, correct? So this is normal doubly linked list. Now I want to add one item in the front, correct? So suppose I want to add one node. Okay, let me delete this portion, it will be easier. Okay, I want to add one node here. It will have at this number, and location of this node is 500. So in a memory, you always need to keep a space for your newly created node. Okay, so in our memory, I just allocated the address of 500 for this newly created node. Now I want to add this node in front of your doubly linked list. What we do in case of singly linked list, we simply change the link for the header. Add কৰাৰ পিছত গোটেই নোট কেইটা কেনেকৈ হ'ব, নতুনকৈ লিখি দিম। এড কৰাৰ পিছত গোটেই নোট কেইটা কেনেকৈ, গোটেই নোট কেইটা সব সেমে থাকিব, আগৰখিনি গোটেই সেম থাকিব। বৰ্তমান ফ্ৰণ্ট নোট কি হয়, এইটো তোমাৰ ফ্ৰণ্ট নোট হয়, এইটো মই এতিয়ালৈ এড কৰা নাই, হয়নে? এইটো এড কৰা নাই মানে কি, এইটো ফ্ৰণ্ট নোট, বাকি সেম থাকিব। তুমি এড কৰিব বিচাৰিছা ফ্ৰণ্টত, তাৰমানে the change will occur only in the first node, correct? So I'm just taking one node and the address is 500. I want to add it in the front, correct? So what I'm going to do, simply going to point our header to our newly added node. So now the address of newly created node is 500, and this is our front now, and head keeps the address of our front node. So this address will simply replace with 500. Okay, so now we need to, this link is gone now, correct? We just added this head pointer to our newly created link. Now we need to create two pointers to connect it to our front node, which is our second node now. তার মানে কি, we will simply create this node. Okay, now since this is our front node, তার মানে previous node will be 0, correct? That means this is our null pointer. Now ইয়াৰে address কি মান আছিলে 100. Okay, so 100 will be stored here. Now এইটো 0 আছিলে, first node আছিলে. Now I just added one item, so I need to store address of the previous node. So this will be just replaced with 500. এটা বুঝা? Yes, correct. So same thing for the last node also. This is add front. Now if you want to add an item in the end, what we need to do? Same process, correct? Suppose I want to add another item in the end. Okay, 10 is my thing and address suppose 700. Okay, so I want to add it in the end. So again same process. We are simply going to connect it to our front node, then there will be also a connection to our this node. Okay, both way থাকিব. Pointers will be in both ways. Now the address of new node is 700. That means next address for this case will be simply 700. Correct. Now this is our last node and this is our pointer for the previous. So last node has the address of 300. So 300 will be stored here and last node is the null pointer. Is it clear? It's same. We just need to change the links. In case of single linked list, we just change one link. Here we just need to change both two links, both the links. This one add in N. Here, now suppose you want to add the item in the middle, somewhere in the middle. Okay, it's not like exactly middle, somewhere in the middle. Okay, that means what? We have to take the data first again. Suppose I want to add 12. Now suppose I want to add it here. So what we need to do? We are simply going to okay, we are simply going to remove these links. Okay, suppose the address is key address delete. Okay, 400 is available. So address for this is 400. So we will simply cut this link. That means what? We will add two links here and we will add two links here. Now address, this is your next node. So this is your first, this is your sorry, already added. So address of the next is what? 200 will be stored here and address of the previous will be stored here. And now this thing will be replaced. Array previous will be 400 now. And for this one, it will be 400. Is it clear? The concept is same. In case of single linked list, we remove one link and put the address of the next pointer. In case of doubly linked list, we just disconnect both the links and just put address of both previous and the next node. Here we just have two extra fields. Both will be 400. I added here, right? The address of this is 400. So this node इसके बाद है ये 100 लोकेशन पे जो नोड है इसके बाद ये वाला है करेक्ट सो नेक्स्ट पॉइंटर में क्या होगा 400 होगा पहले 200 था मतलब ये वाला नोड था ना ये नोड था मतलब 200 था करेक्ट अभी मैंने ये वाला नोड दे दिया और इसका एड्रेस 400 सो नेक्स्ट पॉइंटर में ये 400 हो गया करेक्ट अभी ये वाला नोड के लिए क्या था ये वाला नोड का प्रीवियस नोड दिस वन और इसका एड्रेस 100 था सो पहले इसका 100 लिखा था अभी मैंने ये वाला नोड ऐड कर दिया तो मतलब इसका एड्रेस 400 हो गया ना समझ में आया ये बीच में ही है, तो मतलब इसका प्रीवियस वाला 400 हो जाएगा और इसका नेक्स्ट वाला 400 हो जाएगा। यहाँ पे सिर्फ अगर if you want to add something in the front, then only one pointer will be changed, correct? Next pointer change हो गया. If you want to add at the end, then your यहाँ first वाला का previous वाला change हो गया. But if you want to add in the middle, that means what? Your both pointers will be changed. Okay. Others? Just see the picture once. Take 3 minutes. See the whole picture. Then you tell me, okay? For everyone, I am giving 2 to 3 minutes. Just see for a while. Then see if you can understand it. Just think for a while. You can say it's a 2 minute break, or in this break, you just see the picture. Okay, so just remember the notes. For single linked list, we have two fields, data and address of next node. Okay, this is your singly linked list. In case of doubly linked list, we have three fields. One is your data, one is your address for next, and address for previous. So front will have address of the previous, and the third one will have address of the next field. So this is our doubly linked list. So any operations we perform in case of singly linked list, we will simply cut single connection, and in case of doubly linked list, here we are just going to cut two links. Clear now? Okay, if it's clear, I move on. সবাই বুঝি পাইছা নে? You can write in the chat. Okay. So this is all about adding items in the front, middle, and the end. Now you want to delete the things. Okay. So what will be the process? It will be just the reverse one. So here, suppose you want to delete the node in the end. Okay, I take different color maybe. Okay. So now this is our end node. Correct? This is the null. So I want to delete it. Delete at the end. What we are going to do now? We will simply cut these two links and put the address null here. Okay, this is our deleted node now. So we will simply remove the links, and the second last we will point it to the null. this is how we are going to delete an item at the end. So now we want to delete the item in the front. Now which one is the front? This eight data I have inserted, which is our first node now. I want to delete it. Okay, now I want to delete in front. So what I'm going to do, I'm going to simply cut this connection and point the head here, and this will have the address 100 now. Okay, I just override. This is add in front. We will simply change the head link again. We will simply cut these both connections and will point head to the front. Okay, and if you want to delete, we'll simply disconnect these two links and will point the null pointer in the end. Is this clear? How we can add in front and delete?
ma'am.
Yes, Deepa?
Yes, ma'am. Clear.
Okay, clear. Now, if you want to delete an item in the middle, what we need to do? It's same again. We will simply cut these connections and we will again create this link. Okay, then again we will just override these pointers. In this case, it will be 200 again, and for this one, it will be 100 again. So this link got disconnected. Okay, is this clear? Doubly linked list. Clear? Dular said yes. Then yes. Okay. If yes, I just move to next one, circular linked list. सबको समझ में आया? Yes. Okay. Yes. Then I just show you the last type. I'm clearing it. If anyone, okay, I'll take a snapshot, I guess. Yeah. So our next is circular linked list. Okay. So what happens in case of circular queue? You remember what happens in circular queue? Circular queue means in case of queue, what happens? If it's a queue, this is your front, this is your rear. In case of circular queue, it will just point it to the front again. Correct? Circular queue was more like this one logically. That means 0, 1, 2, 3, 4. So whenever we come to the last moment, we can reset the value of front or rear to 0, right? That was the basic operations in case of queue. Now in case of circular linked list, it's just like your normal singly linked list, which will have your data to 6 and will just contain the address of next node. Suppose addresses are like this. This is your last node. Okay, this is your null. The head will have address of your first node, maybe it is 100. So circular linked list will just have the connection back to your front node. That means what? Whenever we reach the end, we can set this to 2 again. Got the structure? Yes. So here also we can add items in the beginning and add item at the end. Middle one will be same, just that if you want to add at the end, whenever it's full, we can always go back to the front one. Now what is the third type? This is your normal circular linked list. Now I say there's another doubly circular linked list. In case of doubly circular linked list, what will happen? There will be another pointer which will again connect to the last one. लिंक लिंक सर्कुलर लिंक में हम कुछ ऐड कर सकते हैं. हाँ, कर सकते हैं. ऐड का सिंपल नॉर्मल ही होगा. Just think about it. Anything else? No, I wrote 0 here, but I just now I said it goes back to first node. So will it be 0 here now? The address of first node will be here. Okay. So in case of normal linked list, no, the address of first node. This is the address of 200 is the address of this one. Suppose address of this is 300. So if it's a circular linked list, what it will do? It will just held the pointer address of your first node. This is your first node. Yes, it's 100. So in case of circular linked list, we cannot say there will be a null pointer. The last node will again point back to your first pointer. So last node will again point to your, will have the address of the first node. Okay. So this is all about your types of linked list. We can just revise it again in the next class. So this meeting is going to end very soon. I'm going to stop sharing and just check your attendance. Doubly linked list, everyone clear? Circular linked list is also just like your circular queue. Just that last node address won't be null. It will point back to the first node again. That's the only difference. Okay, clear, clear. Good. Okay, I am ending the meeting now. Okay, sorry ma'am, আজি active থাকিব পৰা নাই ক্লাছত কোভিড টেষ্ট কৰাব আহিছো মানে কৰাব পাৰিলা নে নাই টেষ্ট নে লাইনত আছা হয় okay okay so this is your circular linked list and doubly linked list then there is circular doubly linked list that means what that will be simply your doubly linked list just that the null pointer will again point back to your first one okay. So I'm ending the meeting here. If you have any connection, we can again discuss in the next class. Okay. Okay. Thank you.